I'm very happy that everybody is interested in such an inspiring subject like biomimicry. It's new for me as well. I'm very happy that Regina, English?
Regina,
she got in contact with me proposing that we get together and find out if there is an interest in the subject where she's a specialist in. Regina lives and works in USA, Georgia. She teaches here. She is a biomimicry specialist, which means that she has made, you are trained in biomimicry, and you're a professional biomimicry specialist, designer.
I can explain it later. Yeah.
And she's a professor in design management in Savannah College of Art and Design in the USA. SCAD. SCAD is a very huge university in the United States. You have 4 locations of SCAD.
Right.
Savannah,
Atlanta, Hong Kong, and Lacoste in France.
France, correct. And she's also a professor of for energy and environmental management in Burgenland, which is in Pinkerton. This is actually the reason why we get together now. She is holding a course in December with engineer students, and she wants to contact with designers in order to create projects which will be
submitted to a competition.
I think in the last few weeks I've heard so much about Regina that it's very hard for me now to sum it up and give you a decent picture about what she's doing. She's doing a hell of a lot in arts, in design, in management, in engineering, I would like you to explain it.
Okay.
So, thank you, Regina, just to hear this, and I wish you an interesting lecture.
Thank you. Thank you. I want to, before I get started, thank you. I want to make sure that this picture is not distorted. So let's do this first. So I'm Regina Rowland again. I identify as a transdisciplinary scholar practitioner. So what that means is that I work in the nexus of various disciplines. In particular, I work in the nexus of engineering, design, and business. And I've studied all these fields, and some of them more into depth than others, but I really work in the intersection between those areas. I'm an educator, mainly. I'm also a consultant and a researcher. And I focus on various things. And in the last couple of years, I've worked my way towards biomimicry. I would say I've worked in the last 5 years in sustainability in particular. And in the last 10 years, I've moved from design and art into organizational work. And this is where I'm going to start with my lecture today. This lecture has 3 parts. So the first part is to just kind of show you where I started, so that you have some connection to the work that maybe you can see yourself in it. And the second part will be mainly explaining what biomimicry is and give you a few examples from the design world. And then introduce you to the project that we're working on. And feel free to ask questions, like interrupt me anytime. Otherwise, I'll just be rattling on, and I won't even notice that you might need a break. So how are we doing this? Is there going to be a break at some point? Yeah. So I'm going to need clues from you guys when that should happen. So the first, this first lecture, which I'm not going to give, I'm just going to show you some pictures. But this is a lecture I did not too long ago at Minneapolis College of Art and Design. And it was about explaining what the trend is in the design world and how design is applied now to various different areas. And so here you can see just the beginning of my fine art background. It was very classical. I actually started here in Vienna and then got a BFA in the United States. So you will probably recognize this as some of the exercises you will do probably. or have done, and I dabbled in a variety of fields, medium, so just to show you kind of where I started. I quickly moved then into installation and performance art, and I was very interested in how to create a multi-sensory experience for audiences, where they also interacted with the piece, where the piece of art was completed by the audience. And so I usually work with different disciplines together, so they show up in my art shows. So these are obviously dancers, and we also had a composer there. And then the audience completes the piece, so to speak. And the reason why I'm showing that is because in this work, my interest moved from working with audiences to working with participants in organizations for particular reasons. So you can see a kind of a pattern here by having a visual piece that then gets picked up by the audience and processed in a particular way for a particular learning. And another piece of work I did that helped me with understanding how to create spaces is 3D design and exhibition design, which you see pictures here. These are still...
You did that?
This one? The Hollywood sign? Yeah. I used to live on the East Coast, actually in Rowland, North Carolina. I went to a school called NC State School of Design, where I got my master's degree in design. Most of my teachers were from Cranbrook. You guys know what Cranbrook is? School of Design. So today it's probably not so famous anymore, but at the time it was very much into the deconstruction. And so if you had a Cranbrook professor, you would have to do the same thing to pass all the tests. And there's a question.
You said you started in Vienna?
I studied in Vienna.
And where and what exactly?
So there's a good story. I was hoping for that question to come up. I actually studied languages at the university, but I was also into art. And I once applied at the Burgenland when I was 18, and I had a portfolio together, and they didn't accept me. So I went to a place called die Wiener Kunstschule. Gibt's den noch?
It's called part nicht mehr.
What's it called?
Oh, sorry. What? Yeah, sie ist gerade am Schließen. They're closing. Yeah.
They're closing. That's too bad. It was a really good parking lot for people like me. And a lot of the people then started there and stayed there for a couple of years and then went on to the academy. Anyways, I went to the States soon thereafter. And I came back one more time, actually to this school, when I was doing my master's at NC State, and I was wondering, because of some life changes I had in my personal life, whether I should come back and finish here. And so I came here, I was 30, and I was not finished with my graduate studies. And I don't remember the name of the professor, but I came into the graphic design program. I showed my portfolio, and that was well received, and then it was determined that I was too old for the program. In fact, those words were used. They would be illegal to use in the United States, but it was said that I should be working, actually, should be contributing to society and not be going to school. So I'm like, well, I'm going to turn around once again and complete my studies in the States, which was a good idea. So, anyways, but I studied at the Dolmetsch Institute, English, French, and German. All right, so this picture is here because my students and I did a book for a famous artist in Hollywood. And then I moved to Hollywood and worked in the film industry for about a year. And from there I moved to San Francisco and studied at CCSF in San Francisco. I'm sorry, I taught at CCSF in San Francisco for about a decade. I was a tenured professor there. And so the reason why I want to show this is once you come to a particular bubble, so LA was a bubble, its own planet, so was San Francisco, its own planet. And when you get thrown into a kind of an environment, you get shaped by that. Your interests spark in whatever is there, if you pay attention. And what was really interesting in San Francisco is that there were all the outliers showed up there. And so when there's a bunch of outliers, things can happen that can't happen anywhere else. So I was really interested in working with...
What's an outlier?
An outlier is someone who would be considered not normal. like off the norm. So any kind of population has a curve, right? And so you have the main population would be in the middle. They behave in a certain way. They have a culture, and then the ones on the other sides would be the outliers. So that's where the name comes from. So anyways, the picture here shows just art that we did on the street, the beach here, for instance, where we ripped out ice plants. And ice plants are not native to San Francisco or to the West Coast in general. So they brought it over to do something, and of course now it's like taken over the whole place. And environmentally, this is really a catastrophe because it kills all the other native plants that are there, that should be there, that keep the ecosystem intact. And so we used some of these really interesting issues for public art. So the people that you see here, I had a couple of my students, and then we just started something, and the people who walked by and said, hey, what are you doing? We invited them in to work with us on this sculpture, which is a really interesting thing. Like, how do you engage the people out on the street in your art? Not just the ones that sign up to come to the show, but the ones that just walk by. And in San Francisco was a really vital place for things like that. These are some pictures of another piece like that. We might call it public art. We worked with a high school that just had some shootings, and then there was a lot of healing that needed to happen. So we used the design process for that. And we did a whole series of workshops with them using the design process. And so this is where I'm now getting into the shift from using design for creating products to using design for creating experiences that are transformative. And we use the word transformative for a change that's systemic. So not just a change that has a particular boundary, but a change that reorganizes your whole system. And we might call this today design management. Which is a new genre in design, and in fact, you may have never heard of it. Has anybody heard of design management? So a couple people. Is it taught here in Europe? Is there a school where they teach it?
There's one school which is in Switzerland.
Okay.
But it's fairly new, it's like 2 years.
Yeah. So we've been teaching it for about 10 years.
There was a school in St. Zollverein in Essen that closed down.
Closed down. Interesting. There's the ones that I know is like maybe 5 schools around the world that teach design management. But the reason why I'm showing you these pictures is because that's where it started, and there were maybe 50 to 100 people, mainly on the West Coast, who used design thinking, is what we call it today. It was made famous by IDEO, the company, right? But there were people that actually developed this methodology. And I would say I was one of them, but we all worked in isolation, like we didn't talk to each other. It's like we were the outliers of nobody wants to hear about how I'm using design, because our design people didn't get it, and the organization of people understood it, but they didn't know how to do it. So there was really no place for it to land or have a conversation with. This you probably recognize. It looks basically like a design studio would work, a bunch of designers figuring out something, right? This may or may not be what a design studio looks like. This is a mixture of using the design process for dialogue around hard issues that you may not be able to talk about, that you may not have words for. And again, it's a multisensory experience. When you talk about deep issues, it usually is not just about talking, it's about feeling, it's about sharing intimate things. Pictures of a transgender community that had issues that they wanted to share with the audience. And here you can see them. These are all non-artists working with visual language to express themselves. It's very cool to work with audiences who are not trained in art. It's very possible to do. In fact, when I go into organizations, people are when you have the right methodology, they're very easily led to be very free with their expression. While when you work with designers and artists, they always want to make everything perfect. So it's very hard to get to the actual work because the wish to make it visually perfect stands in the way of the transformational work. We also worked in prisons. We did a poetry class in prison, and we worked with typography as the visual means, and we couldn't bring X-Acto knives, so we were like ripping letter shapes from paper. and composing them in order to make a visual poem that then was accompanied by something that they wrote. So I worked together with a writing teacher and me as a design teacher together. And then we had a show and a performance, and some of the people that you see here are my students that performed for the people who hadn't come out of prison yet. And some of these people were the actual then released prisoners, free people again. And the interesting part is that the audience couldn't tell who was who in this project, which was very transformative for our subjects as well as for the students. What I noticed in this work also is when you are in San Francisco and you have this multicultural explosion of people, which maybe Vienna could be a place like that, I'm not quite sure. It seems very diverse today. Wasn't so diverse when I was living here 20 years ago. But I learned that I didn't know everything about how to work with non-Western cultures, and it's very different to work with non-Western cultures. So I went to this institute in Portland and studied intercultural communication for 3 years. And then that took me to a very international piece of work. So this is in Jerusalem, where we facilitated dialogues. And when you do very difficult dialogues, you need a multitude of methods to get people to actually share. So when you work with these kinds of folks, or these kinds of folks that show up with guns in their boots to the conversation, you really need to shape the whole environment in a creative way. And this picture is back in my classroom in San Francisco, where once I did this international work, I was not the same person. So whatever I did before didn't make sense anymore. And so I came in back to the classroom, and we did all this kind of creative stuff around how to move people's minds and hearts, basically. And so we developed some of the technology that's now would be very normal in design thinking. You all are familiar with design thinking, right? And what happens there and how you use it in organizations? Yeah, okay, great. So you will probably, this looks familiar to you most likely, if you have done this work or have been exposed to it. And then when you work in organizations, you also, you get to work with groups on a particular problem solution or a particular change piece. And it always includes working with individuals. So you get coaching individuals as well as working with groups on their change piece. And you work parallel with that. So I found that you can use the visual process for that as well. So this is an example of a vision for somebody. This is a process of a vision for somebody. So you as a coach would take a person through a mapping process like that. This is what it might look like when they vision themselves. So there's a bunch of activities that I do with people around this. And then it can be applied also in other areas. So here we are in Africa. I've worked in Africa multiple times. And I've done a biomimicry project most recently last summer. So if we have time, I can show pictures of what we did there. So dialogue process, and what I want you to pay attention to are the images in the background. So we had a bunch of what we call graphic recorders or visual facilitators who create maps in real time of the conversation. And it works best when you also include the participants in the creation of these maps. It's more meaningful to them if they do it themselves. So you see some pictures here of what that looks like. This is in Montserrat in Spain. You see similar dialogues. So this is what we might call a world cafe. Have you heard of a world cafe process before? Yes, it also includes a visual aspect where the participants usually gather around the table. Here they gather just in circles on chairs, and they would also be drawing and sketching on that table while they hold the conversation. These are graphic recorders. A team of 8 people was part of this. It's often a highly collaborative process. So you would draw into each other's map. You don't draw your own map. This brought me then to my doctoral work on the co-construction of meaning, where I brought together visual language and intercultural communication in a frame of integral theory. That's all I'm going to say about that. And then I wanted to let you see what graphic recording looks like. This takes only a minute. What you do here is you work in real time, as you could see from how it was just recorded. But you kind of make a concept of a conversation that's going on. So you don't record everything. You have to, like, on the fly, think about how would I visually represent what's going on here. So this map, usually, this was a map that probably took me 2 hours to do as a process of a conference that was going on. And there might be like 800 people, 800 to 1,000 in that room. And you would get filmed, and then your drawing shows up in different places. It helps the audience to kind of track where they're at in the conversation. It's basically a mapping or learning process for that. So there we go. This is what it looks like. Here's some maps. And this is what it looks like when you teach it. And Misha actually went to that school, so you'll recognize this room, right? These are sustainability for leadership students, master's program, that learned this process. They were not artists or designers, most of them, but they learned this process to facilitate learning or facilitate addressing a challenge in audiences, in participants, in organizations or other groups. Now these are designers now learning the process. And you can already see they were paying attention to different things, right? This is what a large room would look like with the size of the images that you would work with. And then slowly we began to I would say make a catalog, name the categories of this kind of work, because there wasn't a term for it. So we put this on a matrix, a colleague of mine, and there's different terms for it. You might find these terms all over the place. So different templates, and you can actually buy these templates now. There's companies that create them. These maps are usually 4 by 8 feet in size. The reason for that is when you kind of look out into the world, this is the same dimension. And when you replicate that dimension for a viewer, you give them the feeling of like they're stepping into the environment rather than just looking at the environment. So the size is actually very important with this work. And then as a facilitator or a designer who uses design thinking for change processes, you would create your own maps, like this one here, for a particular process. Sorry, there we go. System mapping is a process that comes from system dynamics, which is a particular theory in showing relationships when you have complex issues. And in complex issues, what we say the difference is between complicated and complex. With complicated issues, you know the relationships. With complex issues, you don't know the relationships between the different aspects of a system. And so to make them visible, you draw these maps. So this is an example of and there's particular rules how to do that and how not to do it, also for change work. And this is, Misha, you will recognize this. This is a system map of the department of that school in Sweden with the program. And what they wanted to see is how they interact with each other, different departments within the university and also their clients. What is the connection between the funding and actually where it goes afterwards, the products that they create. And different kinds of maps. This is visual coaching in process. And here's the story that I really want to tell. So this is now design thinking in action. We didn't call it design thinking until IDEO came up with the term, but it's engaging the participants in a process where you use the visual language and design thinking to learn something, to figure something out, to address complex issues. So you can see how they're working on the wall in different techniques and also on the table. We call this kinesthetic modeling. And so people would go back and forth between the walls. We call that a working wall, and with your working table. And then eventually you come up with an action plan. These are some other forms of how you would engage people visually, just to show you the variety. And usually you show up with something, you start with something very abstract, like on the left here, and then on the right you can see a map that is more organized. Eventually that map on the right would show up on a spreadsheet, an Excel spreadsheet, which is what management people are used to seeing. But if they started off with the spreadsheet, they would never come out of their own little box. So the creative process, the design thinking process, the visual language takes them out of their usual thinking and allows to innovate. So that's the purpose of why we use design thinking in that way. Some other photos? Yeah.
I think maybe it would be good to give a short definition of design thinking.
Okay.
Yeah, it would help.
Sure. So let me see. Here's a process, for instance. This is the Fachhochschule in Pinkerfeld from last year that worked on a biomimicry project, and we invited die Wiener Grafische, I forgot what the whole title is. Schule? Die Grafische.
Bundeslehranstalt für die Grafische,
Yeah, you know. So here you see two types of people working together, at least. You see engineers, actually it's three types, because at the FH in Pinkerfeld we have engineers and business people together in this program of energy and environmental management. So you have creative people, you have engineers and business people at this table. And in design thinking, we usually want transdisciplinary people to working together across fields. And you use a creative engagement process like the one that you see on this picture. In this case, it's kinesthetic modeling. But we could also use the wall that you have seen somewhere here with the visual maps on the wall. That's another form of engaging creatively. We use visual language, and visual language has images, words, and symbols that connect the words and the images. But basically it's about getting a group of people together to work creatively through a challenge. That's what we use design thinking for, and we use it in organizations. You as designers use it, but you don't have that word for it. It's just a design process. The innovation was to take that design process out into the organizational world and work in business with it.
Yes, and I think that Tim Brown he brought it to business schools.
Right.
So he created this notion to give it to business as a
Yes.
tool for
Yes.
for the
So
means for-
Tim Brown was a co-founder of IDEO. They no longer own the business. Nobody knows that, but they still call themselves IDEO, and the same people are still there, but they're owned by a much larger company. And they brought the term design thinking, they birthed the term of design thinking. They have been part of developing this process in organizations, as have so many others. The funny part is that they think they have developed the design process, which, it's like, come on, guys. Design thinking has been around since the 1700s, since the first time Toulouse-Lautrec did a poster, maybe. But it is what we really are thankful for by IDEO is that they brought it into the business world, which now means all of us have more of a justification for being there. You all could go there and call yourselves design thinkers and do the work with groups. You know how to do it. It's innately your process that we now are using in businesses to solve problems. Is that good enough? Okay. So different facilitators would use different forms of that, depending on what your background is. So for me, I come from a multiple media, and so I use multiple media in that work. This is what it looks like. So this is a group in Seattle that was working on a transdisciplinary group that was working on an issue that is important for the whole state. It's about oil leaking from cars onto the highways, which then turns into runoff that runs into the Puget Sound water system there and pollutes the water. So now we're thinking about, as a whole community, what can we do about this? There's certainly a technical aspect. You could say, well, we could make a car that doesn't leak oil, or we could make a car that doesn't need oil, and I'm sure people are working on that. But until you actually have that innovation on the market, you still need to work on the social issues. So, you know, if I have a leaking car, why don't I get my oil leak fixed, for instance? Then you have to think about what are the structures in your system, in your social system, that keep that behavior in place. So it's about the individual as well as the structures that the culture has put in place. And now we're in a complex system, right? We have the technology involved, we have behavior involved, we have the structures of your whole society engaged. And so we need to bring representatives from all of these parts, aspects of the system together to think together. And so here you have again a design thinking process in action. In this case, it's a community, not a business, so to speak. And we use biomimicry process for that. So design thinking is part of the biomimicry process. I'm not sure that all the biomimics would call it that. They are not necessarily used to that language. You may find that they use design thinking or not, I'm not quite sure. But here you can see that. Okay, and that was a short lecture. What questions or comments do you have about this so far? Anybody?
Yeah, I'm interested in graphic recording.
Uh-huh.
What do you do after it's been recorded? Do you go there and analyze it, or is it? What is the final purpose then?
The final purpose is, yes, it depends. Could be two purposes. One is to follow the process in the moment, so that the people who are engaged in the process can see what's actually going on, because they're not always tracking where they are in the conversation. So having a map appear while you are in conversation helps a lot in keeping track of that. Also, when it's about hard conversation and it's about a conflict, and you place a comment on the wall, it actually takes it away from the conflict. Like it's like, I've said it, I've heard it, everybody can see it, I can let go of it. So it flattens the field, depending on what the application is. And then when you're done with the map, you usually give it to the client. It belongs to the client, and if it's a big client, they usually scan the maps, and then on a big scanner, like a big drum scanner, and then it lives in their system in multiple ways. When you do the next leg on the facilitation, you bring those old maps back into the room. You hang them up so you can say, where were we? You kind of walk through. So it helps you to stay grounded in that conversation when you take the next step. Or it could also be, if it's a visioning, so if the map is a vision, it has multiple purposes in keeping the vision alive in the organization. So those pictures don't go away afterwards. That's what I'm trying to say. We don't consider them art pieces. So when you're there, the audience usually cannot determine the difference between a good map and a crappy map. They get excited the same way, because they just like to see themselves reflected in it. It's an amazing experience for a human being. They're like, wow, somebody really got what I was saying. But there are good maps and bad maps, or good maps and better maps.
It's like a protocol.
It's like a protocol, yeah?
A visual protocol.
Visual protocol. Mm-hmm. I find it more powerful these days when the participants are engaged in creating the map, rather than you have a person doing it. You might have a visual facilitator just doing the mapping while you have a group facilitator running the group, or that person might do both things at the same time, or you might invite the participants to create the map, which I think is most powerful, because then it's their work. Mm-hmm. Any other comments or questions?
About design maps, what's the kind of the key in creating a good map, or
Yes.
the system in creating one?
Yes. So
What's the difference between design and
Yes.
thinking?
So as visual people, we would notice the difference whether it's visually pleasing or accurate, right? This is not the most important part. Yeah. The most important part is actually for the facilitator to listen well and to consolidate the information that they're hearing into a concept, and then we represent that concept. So a good map is one where the concept is clear, something that the participants didn't necessarily understand when they were talking about it. You have to create this construction while this is going on in real time. And then also when it's visually well represented. I think it makes a difference. I'm not finding that the audience thinks so. For them, it usually doesn't matter whether it's beautiful drawings or not. Okay. Yes?
Maybe, is there a problem with a certain style of people drawing these maps?
And what do you mean by problem? Define problem.
For example, in front of the law, there is somebody typing it. There is no certain
Uh-huh.
style and no attributes of this person in this text. But I could imagine if I would draw it, I would draw it like I usually do.
Right.
Is this a problem to understand from that?
I see, thank you. So the question that you have is, when you do your individual style, does it influence the information, yes?
Of course.
And I would say the answer is yes to that. But when you do this work full time every day, you kind of lose your ego in it. Like it's not about you anymore. I can see that when you approach it as an artist, it's your map, it has to be a certain way to be satisfying. But when you lend yourself to that process and you can step out of your artwork, so to speak, it really becomes, you learn how to be of service to the group in that way. If you can't be of service to the group, you probably won't be doing that work for very long. It's not satisfying in that way. Good, then I'm moving on to now biomimicry. Sorry, I'm just playing around here. So biomimicry is based on the observation that life creates conditions conducive to life. It's a simple thing. You can observe it, you can feel it, you can resonate with it, your cells know that information. And so that's the foundation of biomimicry. And whenever in doubt, we come back to that mantra, so to speak. So when you say, what do you do in biomimicry as a designer, as an engineer, as a business person? I create conditions conducive to life.
I don't know the word conducive. What is that exactly in German?
Was Leben hervorbringt. Die Konditionen, die Leben hervorbringen. Wollte ich was Besseres an?
Unterstützen.
Bitte?
Beitragen, fördern, dienen.
Ja, dienen, gefällt mir gut. Dienen. Also die Konditionen zu kreieren, die dem Leben dienen. Und Leben wieder hervorbringen. Generativ. So here, let's just kind of agree on some things. So we know from science, and when I talk about science here, I talk about natural science as we would agree to it in the academy. I'm not talking about any kind of belief system, because different religions, different belief systems have other stories of how life showed up on this planet and how life evolves on this planet. When we talk about biomimicry, we're talking purely about natural sciences. Physics, biology, subjects like that. So from that perspective, we think that the Earth as a solid is about 4.5 billion years old. And we estimate that there's 30 to 100 million species. We have actually only identified a very small part of it. I think the number is 1.8 million, but I'm not quite sure. No, it's way smaller than this estimation. But what we do know is that they have learned to survive on the planet for 3.8 billion years. And you all know that life started with bacteria, right? And from that bacteria, life has evolved through diversifying, and that's where supposedly we came in as well. We're like on top of that food chain, which gives us the belief that we control nature, we control what's here, and that's definitely not the case. But we are on top of the food chain in some respect, so which is why we have taken that position. In biomimicry, however, we really believe in the respect for life and the love for learning from nature, so that we're not, nature's not subservient to us, but we are subservient to nature and everything that's here in the system. We're part of the system. We're not the authority in that system. That's an important distinction. And somebody mentioned bionic. Somebody did? Yeah. And then there's other terms like biomimetic and all kinds of things. These terms come from engineering, another kind of science. And the difference is that in biomimicry, we really have a focus on sustainability. So what we innovate as biomimics is based on sustainable life forms. While in bionic or biomimetic, you don't necessarily have to do that. Because bionic comes from the German culture, it also has a strong sustainability strand, but it's not one of the requirements. So you could actually figure out a very cool thing from nature, a process, for instance, and then still create unsustainable things from that, and that would still be okay. In biomimicry, that's not okay. It wouldn't be signed off unless it was also sustainable. There's a huge difference and makes it much harder to do. Okay, so I understand I'm going to give this slideshow to somebody so that you also have access to it. You can watch this video. It's a really good example of how nature's process was used for desertification, which means we bring life back into a desert, have plants show up again in places where they couldn't. So you might want to watch that. I'm not going to go there right now. In biomimicry, we have three essential elements that we study, that we practice, and that are part of the process. One is ethos, and in ethos we have two parts. We have actually, as I said earlier, the sustainability requirement. Everything that we do in biomimicry has to be sustainable, or it's not part of what we should be doing. The second part is that we have life principles that were collaborated on by an array of scientists that worked together around the world to establish these 26 life principles that we find in 99.9% of the organisms around the world. And we use those as design principles, basically, in the design process. The reconnect piece is the piece that allows you to build or rebuild a strong relationship with nature. And so for designers, that means, and I'm going to show you some pictures later, we go out into nature, we expose ourselves, we dive in, and we try to learn from nature directly. Because there's nothing better than having the real experience with all your six senses out in nature. Rather than reading about it, we do that also. We definitely go deep into the research when we emulate from nature. But a big part is that you actually have to be out there breathing air and observing the natural world. And then we emulate, and that's the design process, the biomimicry thinking process. I'm going to go into detail with that a little later. And I want to give you three examples of how we mimic nature. We mimic either form or process or system. The best processes are when you do all three of those. And it's not always possible or necessary, but we try to not just do form, we try to do form, process, and system. Because you can emulate from nature and create something sustainable in form, but when you look at the larger system, it still might create another unintended consequence, another problem later down the road that you may not have perceived as you were doing your form innovation. So we're trying to have a boundary that then gets expanded so you can see the whole over time and space. So this is an example of how we emulate form. On the left you see an example from nature. So this is obviously a spider web with a spider in the middle of it. And on the right you see an innovation by a German company called Arnold. This is Arnold glass. And we know that at least in Europe, in other places in the world too, but I know only the number for Europe. In Europe, 150,000 birds die every day from flying into glass windows of our high-rises. And that's because they can't see that it's glass. Has anybody ever ran into a glass door? I too. I have to. It was a really dramatic experience. I didn't break my nose, but I had like a blue face for several weeks, and it was very painful. So I don't expect the death by running into a glass wall is very pleasant. So some very smart people figured out that birds fly through woods, and there's spider webs hanging on the trees, and they don't fly into the spider webs. So then they were asking a very clever question: well, how come? By nature does this not happen? And so then they analyzed this and found that there is ultraviolet light in the spider web, woven into that the spider creates. We can't see that spectrum of light, right? So that's why we don't see the spider webs until there's like some water sprayed on it, and then you can kind of detect it. Otherwise, you all have run into spider webs in your face, right? And you couldn't see it because we don't see that spectrum. So now this Arnold Glass company has developed glass that has ultraviolet fibers in it, like you see on the right. You see those stripes through it. And it's very effective for this bird death. It's a new innovation. You may or may not have heard of it. I don't know. So that was an example of form. Here's an example of process. This is a company called Calera, and this is the Calera process for creating cement that's then used for a variety of building materials. And what's happening here is that in this Calera process, CO2 is captured from industrial waste and converted into calcium carbonate to build strong structures or cement in this case. And nature uses the same mineralization process. For instance, an ecosystem like the coral reef uses the same mechanism. It grabs the CO2 from which is floating in the water and separates it so that and mixes it with other minerals, so that the calcium carbonate then is the main structure of the hard corals that build from there. And so this is an example of the process that we emulate from nature. Here's an example of emulating nature on the level of system. So on the left is a picture of an estuary. And an estuary is an interesting enclosed coastal body. It happens when rivers run into the ocean. And what's happening there is it has an interesting environment between salt water and fresh water flowing through and bringing sediments, and salt water and the plants that grow in that area. And so what happens in estuaries is that the water gets filtered by all of the organisms that are there. And when I say organisms, it's usually everything organic. So it includes plants and animals of all sorts. And so this John Todd has designed the Eco Machine, and this is the English word for Kläranlage would be wastewater treatment system. And it is an emulation of this estuary. And the water gets filtered through these different places, these different tanks. And each tank has a particular combination of organisms in there. And it gets filtered all the way through. And at the end, you get high quality drinking water that is filtered and cleaned by living things, living organisms, without heat. And so in the human world, we talk a lot about heat, beat, and treat, which is what nature doesn't do, and we don't want to do that because it wastes energy and creates, often we use chemicals, poisonous chemicals for that. And so it's an example of how nature cleans and filters without heat, without poison, and merely by the genius of combining particular organisms in a particular space. Okay, so that's the first layer of the examples. I have now a series of examples for each of the life principles. I will not be able to show them all. That would be a 10-hour lecture, but I'm going to stop where I feel like maybe it's a useful example for you. So when we talk about the biomimicry thinking process, we have 4 phases. We have the scoping phase, the discovering phase, the creating phase, and the evaluating phase. And while this might be the way you might think of it as a linear process, it's not a linear process. Just like your design process isn't linear. Right? When you explain it, you could say, well, first I do this, and then I do this. But often you have to go back to stage 1 and start all over again, or go back into your research or redraw a design. And so the same happens here in this biomimicry thinking process. It's not linear, even though I will present it in a linear form. And then when we design, we're really very adamant about staying within these life principles. And that's what I'm going to be talking about. There are 6 life principles, master principles, and then there's sub-principles to each of the 6. And the sub-principles support the master principle, and they embody the master principle. Another thing that's important in this biomimicry process are the operating conditions on planet Earth, which we're all subject to, and we cannot work outside of them, even though we often think we can as clever humans. So here are some things that we need to pay attention to. Most of the living organisms on the planet need sunlight and water and nutrients, and we're subject to gravity, right? The sunlight gets converted into energy. Water is important to live. I mean, most of our bodies are water-based, and gravity means that things, for instance, a tree, the roots of the tree grow downwards because of gravity. They also grow towards the water, towards moisture, and the crown of the tree, the canopy, grows upwards because it's reaching towards the sun. So that's an explanation how things, it's like duh, right? We knew that, but we forget in the design process to pay attention to these very basic rules on Earth. Then we have a dynamic non-equilibrium on the planet. And what that means is that over time, you could say that our systems are very stable. They change slowly, but on a day-to-day level, there's a lot of change going on. You will notice from your life too. So if you look at your life on the first 30 years, you can say, well, I was pretty stable. I moved from here to there. Now I'm here at school. But on a day-to-day, lots of things change in your life all the time, right? And the task for you or for us as humans is to be adaptable to that change and not fight it. So a visual that we give for that, for instance, so if you think of life as a bowl, like a salad bowl, and you think of it as always kind of wriggling around. And then you put a piece of butter in it, and it kind of keeps turning and twisting. That butter will actually turn into a ball because it's malleable, it's soft. It will go with the shape when I roll the ball like that. And when you take the butter out and you put in a very hard, rigid wooden cube, for instance, you can roll it as much as you want, it never becomes round. And so the charge is for all organisms on the planet that are subject to this dynamic non-equilibrium, is what we call it, is to be adaptable to what emerges in the environment. We cannot deny that fact. And yet most of our innovations do deny that they're not adaptable. They're static in that sense. Then we also are subject to limits and boundaries. And how we might understand that is, for instance, you could think of it as what is something that humans need to do. We need to breathe. Or we cannot fly like birds can fly. Those are the limitations that our bodies on this planet are subject to. And we also often forget that as designers and innovators. And then all things living or unorganic matter are part of a cyclical process on the planet. That means there's a day and a night, there's change in temperature, there's change in moisture, there's seasons. Those are things that we are also needing to adapt to. Those are the operating conditions. So for instance, here when you look on the left, this green ball represents all the water that's available on the planet. All the water that has ever been here, all the water that will ever be here. The planet in regards to material is a closed system. So nothing comes in, nothing goes out. That water will always be the same. Now the drinking water, if you put the ball of the drinking water next to this water, it's so tiny you couldn't even see it. It's like at the top of a needle. Yeah. Now imagine what we do with the drinking water and how we waste the drinking water. When the drinking water is gone, all of us who need to have fresh quality water to live, we're screwed, basically. And so this picture really shows the dimensions that we're talking about and how fragile that system really is. And it's all about balancing the aspects that need to work together with each other. On the right, that wall is the atmosphere, a thin layer of air that's around the surface of the Earth. And with that is the same issue. And so this slide is here to give you also a picture of limits and bounds that we're subject to. We can't change that. That just is. There's no more air, there's no more fresh air or fresh water than what we have. Much of our fresh water has been depleted around the planet. And the rest of it we have poisoned. So, there's 26 life principles, and these are deep patterns in nature. And we want to emulate in our innovations these life principles. Because if we don't, we know we're not creating something that is conducive to life. Here's an example of a principle that's called be locally attuned and responsive. And this is about fitting into and integrating with your surrounding environment. This is a beautiful example of a visual example of how that works. Here's another example, and this is a sub-principle. It's called leveraging cyclical processes. This is on the left you see a Namib beetle from the Namibian desert, which is the driest desert in the world. And this beetle obviously has figured out how to get water. As you can see, it's kind of like it's standing up its back a little bit and has the water running to the front, to its mouth. And you can see the water beaded up in the front. And how it does that is that it has figured out the cycle that in the morning, for a very short time, there's fog coming in from the sea. And it comes across the mountainous areas and it crawls up the dune and catches the fog. The way it catches the moisture in the fog is it has these bumps on its back. And the bumps have also peculiar properties. So the bumps on top, the tips on top, they're hydrophilic tips, which means they attract water. And on the sides of those bumps, you have hydrophobic sides that repel water. So what that does, it makes a little drop of water on top of the tip. And then when it kind of bends forward, those pearls of water, those tiny pearls, would be running to the front and create that big bubble in the front that it drinks from. It's pretty ingenious, isn't it? And it is an example of how organisms have evolved into learning how to be with these cycles and how to take advantage of what's here. On the right is an innovation. This is a direct emulation. It's not always a direct. In this case it is. And this is by an Australian engineer who has borrowed this principle and has created this thing that's called a self-powered airdrop pump and underpipes system. And he won actually the 2011 James Dyson Award for this. And you can see there's the coils, and so he's figured out how to catch air into these coils that are then underground. And because it cools, the water will condense, and then he collects the drops, and then it gets dispersed into the root system. You can use this anywhere in the world. Here's another example. This sub-principle is called use readily available materials and energy. So on the left, the biological example is a Dandelion, a Löwenzahn. And this organism uses readily available wind energy, right, to disperse its seeds, to multiply. So there's no need to design another strategy. The wind is already there, and it places itself in a place that's open. You usually find it on a meadow, not under a tree somewhere. And so it takes advantage of that wind to do its pollination across the field. On the right, you see, I think this is a fairly new innovation. It's something that we call piezoelectric. So it's a vibration harvesting system which converts mechanical into electrical energy. And so this is a picture of a floor in a disco where the dancers create the energy that then lights the room and the music, and runs the music. It's pretty cool. We also use this now. This has also been used in Scandinavian countries. In, for instance, a Bahnhof, that's in English, a train station, thank you. A train station where a lot of people like tread by, right? So they collect the energy, translate it and transfer it into electric energy and heat a building next door. So these are things that are already in place. Scandinavian countries are ahead of the times here quite a bit. They lead quite a bit.
There's a very practical example of a light switch. There is a light switch that doesn't need a wire because the action of pressing it produces enough energy to send a wireless signal that switches on your lamp. And that's interesting because wires are difficult to put into old places and into new places, so you save material, but you've actually kept the same functionality.
So the energy gets created by flipping it. Same mechanism as this. Do you also call that piezo then? Okay. Thank you. I'd love to hear about that.
Feuerzeug.
Aha.
It's also piezo.
Yes, that's true. Creates a funken by rubbing it against each other. Yeah, great. These are great examples. Another one, cultivate cooperative relationships. In the organizational world, we would call these cultivate collaborative relationships, but collaborative is not a term that we use in biology. Like, as far as we know, there's not a consciousness in the same way as we do, so in the biology we refer to cooperative. But the example here on the left is a crocodile, obviously, and the Egyptian plover is the name of the bird, and the relationship that they have, and they only do this with this particular bird, so there was some kind of evolutionary process where this developed. The bird goes in and eats from between the teeth the meat that's left over, and the crocodile gets a tooth cleaning. And only those two do that, not any other birds. So obviously, other birds get eaten, so they don't go there. We're not quite sure how this evolved, that this particular bird is involved in this, but that's just what we're observing today. On the right, you see an example from the human world, and this is actually an eco park in Hartberg in Austria. I haven't been there myself, but I want to go this year with my students there. And it's an example of how you emulate from the biology into the human world. So an eco park is a place, and there's several in Europe, where the organizations that build there, that work there, have agreements to work together. So it is the waste of one organization becomes the energy for another organization, or maybe they might share some things that otherwise every organization would have by themselves. And in this particular case, it's also organizations that I believe have to be sustainable organizations, or they're not allowed to build there and be part of this. So it's another form of like a Wohngemeinschaft on an organizational level. You share resources. This is a master principle called Use Life-Friendly Chemistry. And on the left, you see a peacock. And a peacock is an organism that has brilliant colors. You know, when you see the wheel and it throws the wheel, it's just really gorgeous. And it has really bright fluorescent color. Well, none of these colors are actually created with a pigment. They're created by the structure. So the structure of the feather and how the light hits it creates all these brilliant colors. The only pigment that lives in a peacock is brown. All others are created by the structure. We humans, in our clothing, we use heavy metals to create color. And so that's not something that we want to do. First of all, it's a poisonous process. And second of all, we use natural resources that we shouldn't touch. The emulation on the right is called gecko tape. Now you see that guy hanging on something, actually with a piece of tape. It's a very strong tape. And the gecko has these very fine, so on its paws, on each of the paws, it has very fine hair, thousands of fine hair that stick out. You can't see them with the free eye. And at the end of the hair, it has this kind of like a sucker thing that folds flat onto the surface. And that creates an electrical charge that attracts molecules together. And so that's how that tape works. And it's super strong, it's completely non-toxic, and it doesn't decompose. Most other tapes, like Scotch tape, has formaldehyde as a glue of it, which is poisonous. So there are some brilliant innovations around this. Nature builds selectively with small subsets of elements, and what we mean by that, you might recognize this as the periodic table with all the chemical elements that exist on the planet. And it might be surprising that nature mainly uses 4 of these. It uses carbon, hydrogen, nitrogen, and oxygen. It sometimes uses calcium, chlorine, magnesium, potassium, phosphorus, sodium, and sulfur. It less often uses cobalt, copper, iron, manganese, and zinc, and very rarely does it use the rest of the periodic table. So if you think about that, it uses these 4 things: carbon, hydrogen, nitrogen, and oxygen. And that it binds it together in a way so it can also be separated again without creating a problem. What we as humans have done, we've created 80,000 compounds from that periodic table, most of them highly toxic. And that's how we use heat and treat, how we create our materials, and how we make it through the world. No wonder that we have a lot of cancer around. Every time you're exposed to it, you're in danger. The example on the right is something that's called the REACH Accord, R-E-A-C-H. And this is an agreement that comes out of Europe, where only a small subset of these 80,000 compounds are allowed to be used in your innovation, in your creation. And for instance, heavy metals are all excluded from it. And it assures that we at least move more towards a healthy way of creating our materials. And the example here is from a company called Novomer, and they actually seek to use the molecules that are on this list using as a designer catalyst. They're using limonene, which is an enzyme from lemon peels, to grab carbon dioxide and monoxide molecules. And they assemble and disassemble them so that it becomes decomposable plastic materials. Okay? So again, nature uses mainly these 4 elements when it composes things together, and it also separates them in a non-toxic way, so that when things decompose, they don't create another problem. This is an example from a sub-principle called do chemistry in water. And so on the left you see frog eggs, I believe. And nature uses water for its chemical processes. And water is polar. So that means it has a positive and a negative charge, which means you can mix it really well. We humans don't use polar elements, and so that's like mixing oil and water. So we need to use a lot of pressure to mix our materials together. On the right-hand side, you can see something that's called pure bond, and it's wood, pressed wood, that usually is glued together with a glue that is highly toxic with formaldehyde. And in this case, they have emulated from the glue mussel, which kind of sticks to the rock with a particular protein that it creates. It's like welded to it, and these glue mussels live on rocks of very heavy water and wave action, and it's very hard to stick to it when you have the strong water flowing against you. And so some chemists have figured out that they can recreate this protein from a soy-based material. And so pure bond is a non-toxic wood that is pressed and put together by this non-toxic glue. Here's an example of a master principle called be resource efficient, and this is in regards to material and energy. So you can see here the honeycombs that bees create. They are hexagon shaped, and we know that this material is most efficient by being able to put most compartments in the same square, as if it was, for instance, squares and not hexagons. And it also creates, because of that shape, a very strong material. So it's super strong, but it can be very thin. So you save on material as well as on space. An example from the human world on the right is, it's hard to see, but when you get the slideshow, you can check it out on YouTube. And this started in India, I believe. Somebody figured out when you are in these slums, which are, card box houses, put together by leftover material with no windows. It only has a door. And so somebody figured out if they cut a hole on top of the roof and then stick a Coca-Cola bottle that has water in it, it actually functions like a light bulb. So it's an example of using material that's already there. It's not necessarily sustainable plastic, but it's a bottle that's already available, and you just fill it with water, and it glows like a really strong light bulb. And so this went around the world a couple of years ago as a really sustainable method for those kinds of people. So an example of being resource efficient. This is a sub-principle called use low energy processes. And on the left you see an abalone ceramic shell. And that ceramic is the strongest ceramic that we know on the planet. We humans can't recreate it. We have tried many times. We're still working on it. And how it works is that the shell is made from the minerals that are in the water, that get grabbed from the water, and they get combined with the protein that this muscle creates. And then the second part of it is that it makes it into these like wafers, like layers on each other, like a brick house. And then between the layers, it has a very, very gooey protein. And so when there is an impact, whether it gets like thrown against a rock or something else falls on it, the shell does not shatter because it can kind of, those tiles can kind of move because they're stuck together with the screw stuff. And so that's an example. We really have been trying to emulate it, and we have not succeeded yet. On the right-hand side, you have an example of it's called a water cone. It's used in Africa, and it uses no energy to create drinking water from salt water. And so it's very simple. It has this cone shape, and you put the saline water, the salt water at the bottom, and then you just let it stand in the sun. So the water evaporates, it kind of crawls up on the side of the cone, and then it runs down in this nice little bowl at the bottom. And so you have drinking water. It actually can make the drinking water for one person during the duration of one day. And they also designed it so that it has nice pictures, so you don't have to like explain a whole lot. It has pictures of how to set it up and how to use it. Multifunctional design is another sub-principle. And on the left you see a cactus. And a cactus has pleats and spines. And pleats are those kind of folded things that you see like a ziehharmonika. And the function of those pleats is that they can expand when the water is available. The cactus will like drink as much as it can. It will make this big round bowl, actually, instead of these folds that you see on here. And the pleats can expand to do that. So that's one function. The second function the pleats have is they also provide shade. When you're in the desert or in a really hot area, you know how much difference a shade can make on a tree, like huge difference. In the desert, it's huge to have any little piece of shade. And so those pleats have those two functions. And then the spines, which are actually the leaves of the cactus, also have two functions. First, they protect from animals that want to eat it, right? It's sharp. But they also provide shade. So nature, whatever it creates, it usually has more than one function. That's the point here. On the right, you see a human example of something that we call a merry-go-round. I don't know what that's called in German. A merry-go-round, but the kids kind of run in a circle. You kind of like do this. Like auf einem...
Ja, Ringelspiel.
Was?
Vielleicht Ringelspiel.
Sagst du es nochmal lauter?
Regelspiele.
Regelspiele? Regelspiel, ja, so sollten wir Regelspiel. Auf der Seite mit Anfuß laufst und dann, so, okay. So, you can see that on one side the kids are playing, and again, when we use that mechanism to pump water up, on the other side you see a woman getting a bucket with water. Also very much used in Africa. Okay, great. So I'm going to stop now explaining what biomimicry is to you, and I'm going to show you where you can learn about this, how you might get about learning about it, and what the opportunity is for you if you so choose to step into it. So I'm going to show you first the Biomimicry 3.8 site. So Biomimicry 3.8 is the institute where I was trained. There's various forms of training. I took the medium size, so there's a training called Biomimicry Specialist, which is someone who comes from a different discipline and wants to apply biomimicry to a variety of disciplines. So that's me. Then there's also something that's called Biomimicry Professional. That's the person that only wants to do biomimicry. That's a 2-year training. Mine was about a year. And then there's these little entryways, and one of them is what I want to suggest to you. If you're interested, there's an online foundational course, and you find it by going to biomimicry.net, and then you can see it's Education Online Courses Foundational Course, and we just played it, but it's really kind of a nice introduction.
Hi, welcome to the Introduction to Biomimicry Foundational course.
Design as a practice is about clarifying complexity.
So that's something that you can easily do. It costs $100 to take the course. It gives you the basic foundations, probably solidifies what you've heard today. It's kind of like a little entryway. And then if you choose to go this route, I highly recommend that you also buy the handbook, which is an extra $50. It's a 300-page whopper of the theory and how it works. It also explains the 4 processes that I have introduced you to. The person that you saw on here is Dana Baumeister, and I'm pointing you here to her talk on InnoTown. So it's www.innotown.com. And then you look under talks, and then, because this is from 2011, and then you look for Innovation Inspired by Nature by Dana Baumeister. She's the co-founder of the Biomimicry 3.8 Institute, and the institute was founded by 2 women. They are both biologists, and the other person's name is Janine Benyus. She wrote a book called Biomimicry, and the 2 women are actually the driving force behind everything. It took them 10 years to build the institute. It's now big enough to have presence around the world, and the students come from all over the world. They come from various disciplines. So please check this out. And then I wanted to draw your attention to the Biomimicry Student Design Challenge. So every year the institute runs this challenge. And this year, and they give a broad topic, so in this case it's transportation, and it can be interpreted in multiple ways. You have to find a boundary around what kind of transportation issue you want to work with. And the competition starts in early fall and then runs through April this year. And you have to be a student actually to participate. And many teachers like me get classes together and put people in groups. The groups are like a maximum of 6 people, hopefully mixed disciplines. And they work on a challenge, and then you submit it for competition. And then there's a big prize, and it would look really good on your resume if you win the competition, or even if you get like into the first 10 or something. We participated in the challenge last year with the Fachhochschule in Pinkerfeld. This year I actually have 9 teams working on it in the United States as well as in Pinkerfeld. And there's an invitation for you. And the invitation for you is to come to our design challenge day, which is on December 14th. That's a Saturday. In Pinkerfeld, where my engineers and other people that we invite co-create an idea around transportation. It includes to walk into nature with an ecologist, and he will explain some things to us, and then we come back into the studio space and we emulate from what we have learned. We use a kinesthetic modeling process like you have seen earlier in the slides that I showed you, and we're still open for inviting people from different disciplines. I think it's really important to have creative professionals like you, part of it, because every discipline thinks in their own rows. Like you probably don't know how to do some of those engineering things, and my engineers don't know how to make it more creative. Like they think in very boxed in places usually. Okay? So if you want to participate in that, we would love to have you. You'd have to find a way to Pinkerfeld, and you might actually be organizing a trip, right, for those who are interested.
Yes.
And you will be there also in person.
Yes.
Mm-hmm. And the opportunity is to just come to that one day and experience the emulation part, a part of it. But you could also, if you get really excited about the project, you could become a member on a team and then continue to work with those students together on developing a solution that has something to do with transportation. The challenge to be submitted to the Institute is not due until April, so there's time to continue to work on it and really refine the process. What needs to be given to the Institute is a PowerPoint presentation of 20 slides that show the research that you have done, what you have emulated from nature, how you have applied the life principles and adhered to them, and then show your innovation. I can show you a video. There also needs to be a pitch video. And this is the video that the design students, here we go. I don't know what that other one means. I hope I didn't screw it up. Wait. Yeah. So this is the video pitch that the students did last year. And the people who did the creative part are the people from the Grafische. It shows the process. It doesn't really show the innovation, but it showed the process of how we went about it. So that's what they created last year, and they were working on irrigation system for droughts during the summer in the vineyards. And there was a lot of technical aspects to be solved after we had come up with this idea together. Good. So again, the biomimicry process is all about creating an innovation that follows this principle. Life creates conditions conducive to life. Nature does that without exception. Okay? So that's what we're trying to do. And in the design process, we use the scoping phase, the discovering phase, the creating phase, and the evaluating phase. So in the scoping phase, we start with the question, what does our design want to do? And the to-do part is really important. We want a verb there. And you wouldn't believe how hard it is for us to come up with that verb. It needs to be a simple verb, and it needs to be something that you can describe. And so we work on this quite a bit. The scoping phase is not easy. And then you ask, in what context is this designed to function? And so then you go through the same story. You have to find the whole system of which this thing that you want to do is part. Then you look at the life principles that I have introduced to you two, and you say, well, which of those life principles are specifically important in this context for my design, for the function that I'm looking for? And then you also want to think about how must your design succeed in this context. And so the objective in general is that a successful design will create conditions conducive to life. We already know that, right? By following the life principles. A well-adapted design must meet the functional needs of the design challenge in the context in which it must exist in order to contribute to its success. And that definition is borrowed from nature, where a well-adapted biological strategy must meet the functional needs of the organism in the context in which it lives in order to contribute to its survival. Okay, so you can see the parallel, right, between the two, so how we go from nature to the human innovation. And then at the end of this is the beginning of the design brief. So at the end of the scoping phase, we have the first part of the design brief. Then the discovery phase, it's going from biological strategies and translate those into the design principles. So the first thing is that we take our design challenge question and we biologize the question. So we say, what would nature do? How would nature address this challenge? And then we look for organisms, for processes, or for systems that do that. And we apply various lenses in that process. So we might go out as a naturalist, which is going out into nature and experiencing what's there, observing. And you might be surprised how much you can actually figure out when you just kind of pay attention. And observing is not like you go there for 5 minutes and come back inside, right? It's like hours that you spend becoming nature, like really to connect with all your 6 senses to the system that you're part of. You could use a function lens, which is the question of how does nature do this, right? You could use an operating conditions lens, which is one of the 4 operating conditions that I introduced you to. You could use an ecological lens, so you know how ecosystems work and you look for evidence in that, or a local lens, like what's important here in this particular square meter of Earth on the planet. So really kind of focus in on a particular scenario. And then you discover your natural models. So, and the way you show this on this function card that I showed you earlier in the example is you name the organism, you talk about what the process is, or the system of the investigation, you describe in words and in pictures and diagrams. So that's important for all kinds of people at the design table to understand the dynamics and kind of really paint a nice picture of that. And then so you go from the function to the strategy that the organism uses to do that function. You describe the mechanism by which the strategy is fulfilled, and then you can go and you can describe a design principle, which everybody at the design table will use. And at the end of this phase, you have this full-blown design brief that gives guidance to the design process. Then you have, you create the concept or the prototype. So you have your creative process, of which I have shown you a few pictures. And at the end of this, you have a concept or a prototype. So you might just have an idea or drawings, or you might actually have a 3D thing that you can show off. So you brainstorm and you emulate. And in the last phase, after you have designed with nature in mind, you go back and check against the life principles to make sure that you have not ventured away from nature, from the principles of nature, the laws of nature, and you ask again very broad questions like, is this how nature would really do this? Or you would also say, what would nature not do here? Like very simple inquiry questions, and the more simple they are, the more material you actually get out of it. The more you can really go back to the logic of nature. So those are the 4 phases, and here's just a way what this would look like in process. And now what I have is, I can show you a few pictures of what we have done with the other design class that might be very similar to what we're doing in Pinkerfeld. If I can get there. These are just photos on Flickr. You've already seen this. So here's, for instance, our Marine Science Day. Just going to show you a few of these. You can see we go out into nature, we do field work, so there's particular instructions how you do field work. And we spend a whole day out there. And some of it we do, as individuals, some of it we do as groups, some of it we do with a scientist guide. And then we make meaning from that. So that's what happens. So when we are in Pinkerfeld, we'll go out into the woods. We'll probably dig a hole and see how everything there interconnects, like how the organisms like the trees and the mushrooms, the relationship that they have with each other. This symbiotic relationship. Nature, what makes nature work is that everything works in an interconnected way. You already know this, but there's a variety of symbiosis going on. We speak in symbiosis of 3 types of symbiosis. One is mutualism, where 2 organisms, for instance, benefit from each other's interaction. Then there's one called commensalism, where only one organism benefits and the other one doesn't, but it doesn't get hurt in the process. And then there's parasitism, where one benefits and the other one loses something in the process. So, but there's lots of win-win things that you can observe. Then here we went to the Savannah River Ecology Lab, and we did an Ecologist for a Day workshop with this ecologist. And so you can see where we really investigate what's there, we touch it, we collect it, we collect it in one part of the river, let it out on the other part of the river, and we also get to kind of like touch some of these organisms. You can really investigate them. And so, once you handle a turtle like that, you have a different relationship with it, rather than seeing it in a book. Right? It kind of touches your heart and your feelings in ways that are not possible otherwise. So that's the important part. Like this guy here, you see he's like, I held a turtle. And you could just kind of see his whole system light up. It's quite an amazing thing. Most of us are not in touch with nature like that anymore. And I'm not sure that ever was the case. For instance, we did a workshop last year in Africa in the summer, and I was really surprised that the African students that we worked with were out of touch with nature just like we are. And I didn't really expect that, because they have their feet on the ground and they walk 2 hours to school in the morning. They don't have electricity like we do. And yet they were not taking care of their environment. They did worse things than we would ever do. And I came to learn that it's really about, you have to build the awareness. It's not enough just to be in connection with it. You also have to be aware what that relationship is. And that's a higher developmental stage than what we had before. So when we say, well, how we used to be in contact with nature, I don't know. Was it really different 100 years ago? Did we really care more? Maybe not. Some of the indigenous cultures that we always point to are not doing that today. So I don't know what happened, where the gap happened, if there was a gap. I just know that it's not enough to put your feet on the ground. There's also an awareness that needs to be developed.
It's just that industrial revolution happened.
Actually,
we
yes.
now have the possibility to waste our planet like hell.
Yeah. That's where we usually say the beginning of the Industrial Revolution. But I don't know what happened before. I mean, I can't say that before it was better. Who knows? And here's again the design charrette. And so this is the process that you're invited to. If you choose to come to this charrette, we would have prepared already the scientific part, and then we'll go through a process like that. We'll teach you about the nature concepts that we've learned. We'll go out into nature with our ecologist and roam around in the woods for a couple hours. And then we come back inside to the design table we built together. And this is basically a brainstorming moment. It's not like we built the whole thing. We build an idea. And then the real kind of design part, the engineering part, and the industrial design part happens after that day. And you may choose to stay with us as part of a team, or you may just have enjoyed that day and learned something about nature in this design charrette process. Is design charrette a term that you use here?
No, I haven't heard it before. Have you?
Okay, but it's clear what it is, right?
I got the picture in the meantime. Is it clear to you?
What do you think a design charrette is? No, okay. Would someone else like to explain it to us? What is a design charrette?
Please, you explain it to us.
I think you can imagine it, but...
Okay, so it's the design thinking process in action. Right, so we're using the design thinking process that you are very familiar with in your design world, applying it to another challenge that may not live within the design world per se. Yeah?
Is it like Savannah, you have to design something and the other have to...
Like a competition?
Question what it is?
No, it's actually a French word and it means a Pferdekutsche. And we use it a lot at least in my context in the design world over there in the United States. What it means is you get a multidisciplinary or transdisciplinary team together, and like in my design school we did design charrettes like once a semester. And what that meant is like you stop all the other work. It would be like this school decides for 3 days you do a design charrette. You get a challenge. So for instance, we had to design the entrance to the zoo in Knoxville. It was a real client. The client comes in, here's the challenge. 3 days, you don't sleep, you don't eat, you don't go anywhere, the doors are locked. You stay inside the school. And everybody, all disciplines participate in solving the problem. That's a classical version of it. It's very intense. You usually get some really cool ideas out of it. Yeah. Good. So I think this is all I have to say. It's 4 minutes before we close.